Everyone, I'm Dr. Pam Maragliano-Muniz, and welcome to Dentistry Unmasked. With me, as always,
Dr. David Rice. Hey, Doc Pam, what's shaking?
hey, not too much. I'm so excited for today because we are spending our time with one of my absolute faves, Dr. Nate Lawson. Nate, welcome.
Hi, Pam. Hi, David. Thanks for having me.
Hey.
So earlier, I was talking to Nate, and I had to reference him as the Bill Nye the Science Guy of dentistry. And I think that's like pretty darn spot on. I feel like, Nate, you've made science interesting and relatable, and we can roll up our sleeves and use your recommendations. And you've created an unbelievable Instagram page. Can you tell us a little bit about that?
Yeah, thanks, Pam. I love Bill Nice. That's a compliment for sure. So we run an Instagram page called Dental Tube with some of my buddies that I teach with at the University of Alabama at Birmingham, and it's a combination of clinical information and scientific information that can be used for clinical application. And yeah, a big part of it is trying to make it so that learning about dental materials, which is my main topic of research, should try to be somewhat enjoyable or less miserable than maybe it was in dental school. So yeah, I'm a full-time teacher, full-time academic at the dental school. And one of the reasons I went back and started teaching was because I felt like learning about dentistry in dental school was maybe just not fun. And it always seemed like very hard, and sometimes maybe harder than it could have been. And so that was part of my goal, is like coming back and wanting to teach, was not saying that I know dentistry any better than anybody else or any better at it, definitely not, but maybe just trying to make it a little bit more relatable and fun and comprehensible, so that like it was just easier to access, easier to understand. And so I'm glad that you said that, because that was a big goal of my teaching style. And then also part of the Instagram was just to kind of showcase that like we can make a topic like dental materials and adhesive dentistry and polymerization and all of these things that maybe didn't sound fun in dental school courses, kind of interesting and enjoyable and easy to digest.
It's fascinating. It's funny. I think back to my student days and what was my experience. And I feel like my experience was overwhelmed. Like when I first started learning about dental materials, I had never experienced any of them before. So it was really unrelatable. And then by the time I had a little bit of experience, I think I was so focused on just surviving that I learned enough really to be dangerous. So I love that you've translated like that chunk of information, and now you help people carry it forward at a time when they have enough clinical experience to say, oh my God, like I have so many aha moments going through your content, and to be like, oh, that's why that's why we do this. And I think those little small doses, but that are super chairside relevant, that they're so impactful. So cheers. And it's easy for us to forget that the data really drives our best choices in dentistry. So thanks for bringing the data to us in a way that's easily digested and totally chairside applicable.
Yeah, thanks. Yeah, it's interesting too, because I guess that's also like one of the big conundrums in dental education, is this idea that like there are certain things that you can teach in dental school, and there's certain things that you can try to teach in dental school, but without clinical experiences, they're not so meaningful. Kind of like, why we see people going back for continuing education, and in the dental education realm, we're like, well, we're teaching those things in dental school and nobody wanted to pay attention to. Now they're spending thousands of dollars to go learn them externally. But I think sometimes, without the clinical experiences, they're not as meaningful. And then when you hear them again after some clinical experiences under your belt, you can comprehend some of these this clinical information. And but the dental tube ideas, is to try to make it, some of it simple enough so that it can be digestible in dental school. But you're right, some of it's not going to be as interesting or as relevant until after you graduate, have some clinical maybe problems under your belt where you're like, oh man, I like got this zirconia Maryland bridge and I realized I don't know how to bond this. And now let me go flip through, Dental Tube or Marcus Blatt's Instagram page, that shows a lot of these clinical techniques or something like that. And then you're like, okay, now I really I need this information and I want it, and you're a lot more receptive to take it in.
I love how your posts are so comprehensive that sometimes you can't even cover a topic with a single post, which I think is really interesting. I like how you sort of develop it and then, really can solve a problem. And I particularly enjoy your page because, yeah, I think you're right. I think that dental school, you learn enough that you need to learn to graduate. But the reality is, and even your best dental school in the country, which I think we could all fight about what that is, the clinical experience is limited. I mean, you're ready to go out to practice, but, for example, you take off your provisional and the tooth prep is black out of the blue. I mean, we don't always know what to do with that. And so I think that I don't know how, sometimes I feel like you're in my brain where I'll think about a burr shape or I'll think about something and I sort of am thinking about it while I'm prepping. And then I'm like, and then I just sort of move on. And then all of a sudden, you've done a deep dive in your post, which I think is so awesome.
Oh, thanks. Yeah, no, it's funny you talk about like burr shapes and things like that. Like even some of those like small little minutia details of dentistry that you don't think about have such a big impact on like what we do. And I remember doing that with like the 58016 diamond that I had used, though we were given in dental school, that I was using to make all my crown preps. I never sat and thought about it. Like, what are the actual dimensions of that burr, and how does like the radius of the diameter, like the diameter at the tip of that burr affect what my margin thickness is going to be? And like the numbers in the burr have no correlation to like the radius of that burr, so you can try to figure out what your margin thickness is. And so I had to go, that was the origin of a deep dive into burrs. It's just, so I was like, I wonder what the actual thickness of my margin is if I just put half of the diameter of, or half of the diameter of my burr into that tooth, and going back and calculating that based on like the taper of the burr, because like the number you get of the burr is not actually the tip diameter, it's at the I guess the fattest portion of the burr. So having to go back and calculate that. So yeah, some of those little like details of dentistry have been fun to explore. And that wasn't even totally science. I guess it was just like going through and making little measurements on the burr and reading from a lot of time spending on the internet searching about these little information from manufacturers about certain products to have made it into Instagram so that other people don't have to go through and do that minutia detail searching on the internet. But yeah, no, that's kind of yeah, some of those are fun little topics to explore on Instagram and those posts.
I think they're making dentistry better, and I think that you're really doing that, which is really important, especially when it comes to relevant topics right now. Now, I know you are kind enough to give us a teaser on some of the things that you have to come. One of which I think can either seem really stressful and maybe daunting to somebody who hasn't done it or has done it a limited times versus somebody who's doing this all the time, are those injectable composites with a clear matrix. Can you tell us about what you're studying and what we can look forward to?
Yeah, no. So we've kind of approaching this topic from both the matrix material itself and from the composites that are being injected into them. If anybody's not familiar with this technique, essentially you would have like some fractured incisors, let's say, and you could either take an impression and pour it up and wax the teeth up, or you could digitally design them and 3D print a mold or a model, sorry. And then once you have either your physical model or a physical stone cast, or if you have a 3D printed physical cast, you could use a clear PVS material to take impression of your waxed up tooth. And then now you've got a matrix, and you put little holes in the incisal edges and you squirt flowable composite into it. So we thought we'd look at the matrix materials and the flowable composites. With the matrix materials, we're thinking, well, what are relevant things we care about? Well, one would be how translucent it is, because it's nice to be able to see through it so you can see where you're injecting, because you don't want to have bubbles or over inject. How much light would go through, because if you think about this, these things are like, it can be 6, 7, 8, 9, 10 millimeters thickness of clear PVS. We want to make sure we fully cure our composites through them. And then the other one that I hadn't thought as much about, but this was from talking with people with more clinical experience, is how rigid the material is. Because if it's too flexible, that's not hugging the tooth as much, then it's not providing as good of a seal. And so when you're injecting, the material can flow beyond the margins, and you got a lot of flowable to clean up. I've tried this technique exactly once, and that happened to me. Like it just there was a decent amount of excess to clean up. So we've looked at translucency of some of the different clear PVS materials, and they actually are pretty translucent. We sent off our materials to get tested as far as like how much blue light passes through them with a collaborator at University of Florida. And then we're trying to figure out how we're going to measure the rigidity, if it's compressive modulus, elastic or tensile modulus. So we're going to try to measure the rigidity of those materials. So, I mean, we haven't exactly finished testing that side of it yet, but that's our intent. We also are going to, there's a new system from 3M called Filtech Matrix, which is a 3D printed matrix material. And so we're going to look at that 3D printed material and also compare that to the clear PVS materials. And then on the composite side, we're going to be looking at some flowable composites. And we thought, well, what's relevant there? We want to know how strong are they, because we're building up, a class, something essentially like a class 4 out of composite. We don't want it to fracture. How wear resistant is it? Because people are putting this on occlusal surfaces and incisal edges. How well is it polished? Because, these are a lot of times going to the anterior part of the mouth. And how radiopaque is it? Just so you can see these things radiographically. And I think those were the relevant properties that we were going to test. Now, we haven't quite got there yet. One of the first things that we did, though, was try to characterize these materials. And we burn out all the resin and measure how much filler is left so we can get filler weight percentage. And that was pretty interesting to find that the flowable composites got a really bad name in the 90s because they were like 50% filled, whereas the typical composite is like 70 up to 80% filled. And so they had super high shrinkage and low flexural strength and high wear. But like current flowable composites can be almost exactly as highly filled as packables, like getting in the high 60 filler weight percentage. So, I'm not expecting them to perform too much worse than packables. We'll eventually try to measure shrinkage stress, which is the only thing I'm really kind of worried about with flowables, is if they have a higher shrinkage stress. But current flowables actually are pretty, when measure flexural strength per se, they're not that different than packables. So, the bad name that flowables got in the 90s, I don't think they deserve to get in the 2020s. So that's kind of a little sneak peek into like what we're planning on doing with that technique and the materials involved with it.
Really cool. Are you guys also going to look at, heating packable composites as well, or restricted to flowables?
Yeah, that's a great point. We actually, when we were talking with 3M about the project design, because we're asking them to print some of their matrix material, they had mentioned, well, if you're using that Filtech matrix system, they actually recommended to be used with heated packable composite rather than flowable composite. So they said, if you might look at our system, you should look at like heated Filtech Supreme. So we're also going to look at some of the properties of heated packable composite. I mean, we haven't done a lot in our own lab looking at heating composite, but there have been a lot of other researchers that have looked at heating composite, and actually it can improve some of the properties of composite by heating it up to that 68 degrees C that some of these composite heaters will do, like increased degree of conversion, which can help with strength, and it doesn't seem like it negatively affects any of the properties of composite by heating it up.
Awesome. Can I ask if there's like not to do's? I see a lot of posts out there and people start talking about heating composite, and I've always been an advocate of just make sure you get the proper composite warmer. Like, don't tape it to your light, or don't buy like the $5 coffee pot thing and cook it. Like, are peers of yours who are really studying that looking into how much heat is too much heat?
No, I've never heard of that. I've never seen a study that looked at like what temperature is too high of a temperature. I'm sometimes can be a cheapskate, and so I looked at getting the coffee pot warmer and finding out like if you set the coffee pot warmer to the right temperature, and I've stuck a temperature probe in the inside of a composite and looked to see what temperature to heat the coffee pot warmer too in order to get the proper internal temperature. Like you can achieve an internal temperature that's correct with the coffee pot warmer. But yeah, if you don't know what temperature to set it to, and just arbitrarily turn it up real high, you would think that there'd be a temperature where you start somehow prematurely setting the composite and decreasing properties. So yeah, I think yeah, maybe if you set it on just something really hot and you have no idea what the temperature of the thing you're setting it on, that seems like that could be dangerous. But yeah, have you played around with that? There's a gun from Adent that they make now that will heat up the composite in like a minute, which is really nice, and it keeps it heated, because that's one of the things I found with composite warmers is that if you take the compule out of the composite warmer and then put it in your gun, in that like 30 seconds it takes to do that transfer, the composite temperature is really decreased. And so that the cool thing about that gun is it keeps it heated up to the point of injection. How long it stays heated while it's being inserted in the tooth, I don't know, but like at least it keeps it heated up the whole time that it's in the gun. Also, I didn't really believe that it could heat it in 60 seconds. And the first time we tested it, it didn't. It took like 6 minutes. And then we found out, I think I just wasn't pressing the right buttons or doing something wrong. And I tested again. It really could. It was like less than 60 seconds. I could get it all the way up to the 68 degrees C. So that was neat to see that. That is a neat little product. I forget that. I think it's called the Compex HD gun or something like that. That will heat it up in 60 seconds. So
very cool.
That's very cool. Don't worry, I'll add a link to that so you can check it out. You also did something which I thought was really cool for a few reasons, because I think a lot of us, if we don't rubber dam on every single patient, some of us will beat ourselves. Okay, I'm going to talk about myself. If I don't rubber dam everybody on every single patient, I think about some of these gorgeous biomimetic posts and I'm like, I just suck. Okay. And so you posted a whole thing about rubber dam versus saying using the dry shield or one of those, one of those devices that will not only, help to keep the mouth open. Because I like that, because I find I'm more efficient if the patient doesn't have a chance to open and close. So I kind of love that.
Oh, yeah.
But then you took it a step further and was like, you're reducing humidity if you're using one of these other types of suction devices. So then the question is, what's better? No moisture or no humidity? Let's weigh in on that.
Oh yeah, no. This is a funny story behind that. Was one of my clinical mentors, someone I work with. I think you guys know Augusto Robles, and he's the guy that like got me really back into using rubber dams. And I think we actually initiated the project to compare the humidity in the mouth of a rubber dam versus an isolite, because he wanted to show. I mean, we kind of thought that the rubber dam was going to produce less moisture than the isolite. So we went on Amazon and bought a hygrometer, which I think was like, measures humidity. I think it was like for measuring the humidity of your lawn or something like that. But we found a dental student and just put it inside of her mouth with the rubber dam and with an isolite in there. And to our surprise, kind of found out that the isolite had lower humidity than using a rubber dam. Particularly, if the rubber dam had a leak in it, it was way worse. Even if it didn't have a leak in it, though, the isolite still provided lower humidity. I still think, the thing that Robles and I will, still talk about is that the rubber dam will prevent circular fluid, like you said, better moisture control, whereas the isolite's not going to provide that. So, I still think like if you can get a rubber dam for like direct composites, the rubber dam is still probably, I feel like, better at controlling moisture. But like, that, like you said, it's the clinical reality is that it's just not always possible to get the rubber dam on there. It's, either from like a, standpoint of the patient's anatomy and what they can tolerate and what they'll let you do. And then also from a time standpoint of just like being realistic about it. So I feel like the isolite is, I don't know. There's a lot of advantage of it. It's great at like keeping the mouth open, keeping suction out of there. It's a consistent spit sucker. Like I think not. I I think I always kind of say like the assistants that I work with at the dental school, I mean, they're great, but like a lot of times they're overworked and trying to do a whole bunch of stuff. And so sometimes I'm left all by myself and I'm like, now I'm trying to hold suction and drill. And so like the isolate never leaves me. It's just always there for me throughout the whole procedure. So yeah, I mean, and the fact that there's less humidity, is kind of a plus, because there was a neat study that again Blatz posted that I hadn't been aware of before his post, that showed that they did bond strength studies in a patient's mouth with and without a rubber dam, and found that if you use a rubber dam, just doing it in the mouth, the humidity reduction by using rubber dam helped improve bond strength. So I'm thinking, wow, well, the isolate reduces humidity even more, so that could be another, an advantage of bonding with rubber dam is reducing humidity, but it's not going to get rid of moisture. So I guess you have to do that somehow else, either, I don't know, just sometimes I think your matrix, matrix band and a wedge and everything like that in class 2, a lot of times that can provide isolation from moisture. So if you get the humidity effect from the isolate and you got a really nicely placed matrix band in there controlling moisture, then I could see making an argument that that's just as good as using a rubber dam. I don't know. I'll have the biomedical community upset with me.
Well,
but
and we're going to put that on your shoulders.
Oh,
yeah.
no, I know. Well, it's true though, but I feel like sometimes you have to have another approach. So, David, have you ever put a rubber dam on somebody who's claustrophobic and they only tell you after you've put the rubber dam on?
That would be my mom inserting veneers on 7 through 10, literally 14 years ago. And I remember the day like it was yesterday.
Yeah, there's nothing quite like placing the rubber dam and you're like psyched about the position of it. And all of a sudden the person attached to the rubber dam is freaking out. And I'm like, now you have to calm down so I can take the whole thing off. And what a bummer that is. So, I mean, sometimes we do need another plan for some of the things that we do, but it's also nice to know that sometimes your plan B might be as good or better than plan A, or, a well-executed plan A. So that's really, really cool. And I think that makes us feel better sometimes if we can't do what we always want to do all the time. So
yeah, it's really cool when it's not that we're challenging that rubber dams are excellent. Literally, they're amazing, but I think it's really a great evolution and a tribute to, people like you, Nate, who explore what are all of our options that are, legitimate options that can be helpful to us in a practice world, given a patient, a scenario, and the day of the week and the full moon that is happening or not.
Yeah, it's interesting. It's funny. That's something I'm interested that you brought that topic up, because that was something we kind of posted, didn't talk much about, probably just because I didn't want to like stir up the the rubber dam fam, but it wasn't I mean, I do use a decent amount of isolate, and I like using it, and it was kind of neat to see that in the study, just to see it could control humidity. So thanks for bringing that up. I actually hadn't thought about that in a while. So
we use that all the time, all the time, like in just like that reference. I think about it like the hygiene side of our practice. Our hygienists are not going to place rubber dams, put sealants on all day. It's just never going to happen. But to be able to have strong relative isolation and feel confident and know we're controlling humidity, that's a win that we can do all day, very realistically.
And that's what I love about, I felt like one of the really cool things that I get to do is talk with, people that are just killing on the clinical side, like you guys, that can have take the stuff we're doing on the science side and then really get trying to find the clinical benefit from it. Because I mean, I see patients, but not as many as you guys do. So it's getting to figure out, one, how the science we use can be applied. And then also it's fun to hear about clinical problems, so that we can go back to lab and try to figure them out. Because there's things that I think about that are clinical problems, but this limited the kind of dentistry that I practice, because I have to be realistic with how much dentistry I can do, because I'm only doing it a half a day a week. So it's usually just fillings and crowns, and but there are other clinical problems that people come up with about full mouth cases and stuff, and they're like, well, I'd really like to know this, and then they tell me, and I'm like, oh, we could try to figure that out in the lab. So no, I hadn't even thought about using the using isolite for sealants. But yeah, that makes a lot of sense.
It's really efficient too, because you can do one whole side really, really easily. So it's actually wonderful. And I also think the way that you describe it is helpful because, for example, the humidity thing, I know I'm like hung up on this today, but I can explain that to a patient. I'm like, hey, it's really humid in there and it needs to, we can't have that. My restorations don't bond as well. And they're like, oh yeah, stuff that thing in there. And you're like, that's right. So I think it's for patient acceptance too.
Yeah.
And it's funny how dentistry cycles, right? Things, become trendy and popular. So rubber dam fam is like rubber dam's all the rage right now. And in another 5 years, it'll be gone. And we'll all know it's a wonderful thing to use, but it won't be cool and hip and trendy, and they'll be into something new. And so it's great to have, channels like yours and people like you who keep these things relevant that need to stay like in the forefront. We can't forget for another 2 decades that rubber dams are, a valuable part of our process. So I have a question for you. Like, we're talking about like new things that are coming, and how much work are you doing assessing like 3D printed resins that are coming to dentistry like fast and furiously?
Well, it's funny you should ask. We're doing a lot of research in that, because it's like, I feel like being in the research field, things come in trends. I remember like when I first started getting into it, like zirconia, that was when Bruxer was first coming out. So everybody wanted to do research on zirconia, and then like bulk composites got to be really hot, and universal adhesives, and like all these things would, as they first came to market, that we get super heavy in the funded research to look at these. And that's 3D printed resins has been the thing that has probably been the biggest source of funding for us for research over the past 3 years, I'd say. It kind of started when we first started doing it, there weren't permanent crown materials. We were doing like denture-based materials and denture teeth materials. And then within the past probably 2 years, permanent crown materials for 3D printing have become more prevalent. I think it would be because there was a change in the ADA website and their glossary of terms that a dental ceramic could be defined as something that contained 50% or more ceramic. And so like the fillers that we use inside of like any resin composite, like our like direct composite resins, but also 3D printed resins, have ceramic fillers in them. And some of them, they figured out a way to get 50% ceramic filler in these 3D printed resins. So that means you could do your ADA CDT code for a 3D printed crown as a permanent crown now if you use one of these materials that has over 50% filler in it. So there's been a couple companies like Sprint Ray and PacDent has one, and Desktop Health, and a couple of these different companies have released permanent crown material. So we started looking at strength properties and wear properties of these materials. And the thing that we're still trying to figure out why this is so is that they actually have some properties that are more favorable than lithium disilicate, which I was not expecting. Definitely not strength. I mean, strength, lithium disilicate is definitely much higher in like the 350, 400 megapascals, where all of these 3D printed resins are in the around 100, 120 megapascals that we test. But wear properties, we actually found less wear of the 3D printed resins than lithium disilicate. It was so weird and shocking to me that I actually ended up sending some specimens to someone I know both of you guys know, Taser Suleiman at UNC. I was like, Taser, dude, like, what is going on? Like, maybe there's nothing wrong with our machine. Test them in your machine. And he's like, okay. So he tested them in his machine and found out the same thing. So we're a little bit scratching our heads on this because it doesn't really make sense that the 3D printed resin that's got 50% filler in it would have less wear than a lithium disilicate, but that's what we've found right now. So yeah, I think the advantage of 3D printing a resin-based crown is probably going to be time and cost, because cost. I mean, you get all set up with 3D printing for probably under 10,000 with the printer and curing units, whereas setting up a mill is going to be way more, and the material costs are just these tubs of resin, which are about $400, and you could probably get 100 crowns or something crazy like that. It's only a couple dollar cost. And really, there's not much upkeep on them. Like you don't have to buy the burr. I mean, we just got a mill. It's super awesome. But like those burrs that you put in the mills are expensive. And, and you had to go through those. Whereas with 3D printed resins, we haven't really had much upkeep with our printer. We've had it for like 2 years. And see, it's a lot lower cost on fabricating 3D printed crown materials than milling them. So I think that's going to be probably the big advantage there. And it's promising to see that the wear properties are pretty good. Eventually it's going to have to come down to some clinical trials. We're not involved in doing those, but or people kind of beta testing them intraorally to see if some of these things we find in the lab are going to show up in the clinic, how well they're going to survive in the clinic. Will be interesting. But yeah, there's definitely an economic advantage of 3D printing crowns versus milling them.
It's such an interesting thing right now where I was just at a course in Brazil, but I guess in March, and Pascal Magnier was speaking, and he was saying, what do you have to do? Like, do you need the hardest, strongest material out there, or having something that's a little bit more forgiving? And it's kind of a philosophical, conversation at this point. But as somebody this morning, not too long ago, had to literally prep a lithium disilicate crown on the tooth because I couldn't get the damn thing off. And, it was, I did it, I bonded. It was one of those that patient came back on hygiene, even though I take, seating x-rays and post-op x-rays, came back on hygiene. And I was like, that margin just is not sparking joy. And I know I want to do better. So I knew I was setting myself up for a nightmare just because I knew I bonded it. It wasn't done that long ago. But oh my gosh, taking that thing off was terrible. And so I feel like, there's something to be said about having a material that's just more forgiving and something that we can work with a little bit more favorably. So I don't know. I guess time will tell and we'll see. But I feel like the older I get, knowing that I'm not old enough that every restoration I place today, I may never see again. It would be ideal if that was the case, but I know that there'll be some that I'll have to revisit at one point or another. And I think, being able to go back and redo or something that, you can fix, I feel like there's something to be said for keeping it simple.
I feel like I'm entering that final season / geographic success era of my restorations because, how much longer can I do this thing 30 years later? But Nate, this is awesome. I could talk to you for 100 hours on all of these topics. So I hope we can drag you back here kicking and screaming because there's so many more questions I want to ask you. But Pam, I know you're going to crack the whip on us here in a second. So
I am. I'm sorry. We are out of time. Do you have any last minute final thoughts for us?
No, just if anybody wants to check out our Instagram, it's called @DentalTube, and we post information about kind of the cool things we're working on there. But thank you guys for having me, and it's fun because every time I have these conversations, I learn a lot too, and it really makes me think, especially that last comment that you made, Pam, about thinking about the replaceability of our restorations, and I hadn't thought about it that way. So I had a lot of fun talking to you guys, and thanks for having me. And I'll be back sometime in the future. That'd be fun.
Thanks, Nate.
Guaranteed we'll have you back. So, all right, everybody, we will see you next week, and I hope you have a good one. See you then.
Cheers.
Thank you, everyone, for watching or listening to the show this week, and thanks to our guests and sponsors on this episode.
Please check out our social media at Dr. Pamela_Maragliano and at Dental Economics Official.
Or you can check me out at Ignite DDS or at Dr. David Rice.
And go to dentaleconomics.com to receive dental economics. You can choose to receive DE in print or digitally, and you can also get the details of our Principles of Practice Management Conference on our website.
If you have topics or guests or anything you'd like to talk about on the show, send us an email to dentistryunmaskedpodcast@gmail.com, and we will do our very best to make it happen. Thanks again, and we'll see you next week.